Michael the Physicist channel. Today I'll be taking you the topic dimensional analysis. I'm sure you will enjoy the solution. I will be taking only one solution today and I will solve many questions as we proceed. Alright, the question that we're going to look at today is derive the dimension of surface tension. The question is derive the dimension of surface tension. Alright, so let's write the solution. Solution. First of all, when you are finding dimension of any quantity, you need to know the formula for that particular quantity. So the formula for surface tension, or what is surface tension? Surface tension is a force acting in a liquid, causing the liquid to behave as a straight elastic skin. So for you to obtain the dimension of surface tension, we have to connect the formula, and the formula is force per unit length to obtain the dimension of surface tension. So the formula is surface tension is equal to force per unit length. One fundamental thing we're supposed to know about obtaining dimension of any quantity, we work with the three fundamental quantities in physics, which are: one, we have mass. Mass, we use capital letter M to denote mass. We have length or distance, we use capital letter L, and we have time, we use capital letter T for it. So any quantity that you have to obtain its own dimensional analysis, those quantities supposed to be expressed in the form of mass, length, and time, or current. So dimensional analysis, we have surface tension here as force over length. So now, for you to simplify this formula further, so that you can obtain these quantities in the formula here, we're supposed to express the formula for force, and force is obtained by multiplying the mass and the acceleration. So we can write this formula as mass in square brackets times acceleration in square bracket over the length. Okay, so now what is the dimension of mass? We said that mass is obtained or is written with capital letter M. So this is capital letter M for mass. And then acceleration, the dimension of acceleration is length per square t. That is length times t raised to power minus 2 over the length, because length is already here and we are using letter L, capital letter L, to represent length. So this is the expression. So now we have to write this one in a linear form. And writing in linear form, we have M L t raised to power minus 2 times L raised to power minus 1. Understand that this L that is here, under indices we have, if we have L over 1 over L is the same thing as L raised to power minus 1. So we have this. So you know that L and this L, they are multiplying each other. And based on lots of indices, when you have two bases multiplying the same basis multiplying themselves, you add the indices. So here is raised to power 1, this L is raised to power 1, this one is raised to power minus 1. So we have to combine it together by adding the indices, which is 1 plus minus 1, and that will give us 0. So it means that this L becomes 1. Then the formula becomes L or M times T raised to power minus 2. And this is the dimension of surface tension. I hope you enjoyed the solution. If you enjoyed the solution, click on the like button and then share. See you next time. You are enjoying more of my videos. Thank you. Bye.